Hi, in this video we're going to look at the topic of similar triangles, which is a GCSE higher topic. As ever, if you want any more information, you can contact me, Mr_G_Walton on Twitter, or you can follow the school account, which is at Tupton Maths. In this video we're going to look at and understand this idea about similarity. Now, basically what we mean is triangles have to be similar if they've got some properties that are the same. They're basically going to be proportional to each other. It's not enough to think that a triangle looks a bit like another one, so therefore they're similar. This is one of those words that has a specific meaning in maths that might have a different meaning in the real world. We might say that two things look similar because they share some characteristics in the real world, but in maths we've got to be very careful. There's only specific things that we're looking at in terms of similarity. Let's have a little look at this first example. It tells us that triangles ABC, which is this triangle here, ABC, and PQR, are similar. Before we do anything else, let's just have a look, see what else is drawn on this picture for us. We can see that we've got an angle here, denoted by one line, that is the same as the angle here, denoted by one line. We've got a double line here and a double line here. This is showing us that if we increase or decrease the size of a triangle, but keep the angles the same, it's only the lengths that end up changing by some given scale factor. They're being proportionally increased or decreased. Okay, this word proportion is really important here. They're staying in proportion. So the question's asking us to work out the length of PQ. That's this line here from P to Q. Let's have a look, see what information we've got on the first triangle to help us. Well, AC was 4. PR is 10. Can we work out by how much AC has increased to get to PR? And by that I mean by what scale factor has it been enlarged? So can I times 4 by something to get to 10? Well, to work that out we can do the sum. 10 divided by 4, that will tell us what our scale factor is, equals the scale factor. Now 4 goes into 10 2.5 times, so our scale factor is 2.5. That means that each side has been multiplied by 2.5. Let's just check. 4 times 2.5 is in fact 10. So 5 multiplied by 2.5 is going to give us 12.5 centimetres. So this side is going to be 12.5. Calculate PQ, 12.5 centimetres. It doesn't ask us to, but just for completeness, why don't we work out the length of QR as well? So BC down here was 6. QR here is going to be 2.5 times bigger than 6, which is going to be 15 centimetres. So I've done 6 times 2.5 there to get to 15. Okay, next example. In this example it says triangles ABC and PQR are similar. Okay, and we can see by that we've got this common angle here, 22, and it also tells us in the question that they're similar, so that means that the angles here will also be 54, and this angle will be the same as well. So even though the triangle has increased in size, the angles don't. The angles stay the same. Okay, first of all it says work out the angle Q. So that's this angle here. That's using the knowledge that I've just mentioned, that even though my triangle has increased in size, the actual angle itself will stay the same. So we can use our normal angles in a triangle facts. So we've got 180 degrees in a triangle. Let's take away, or what have we got? We've got 22 and 54. 22 and 54 is 76. So So I'm taking 76 degrees away from 180, which is going to leave me with 104 degrees. Work out the length of PQ. Now that's the length here from P to Q. So I'm looking at the corresponding side. It started out being AB, and that was 8 centimetres. Now we need to know by what can I multiply 8 centimetres by to get to the new length PQ. Well, I've got some information shown here that BC was 5 and QR is now 11. So something has happened between 5 and 11. It's been increased by something. In order to work out what that scale factor is, I can divide 11 by 5, and I can use my calculator to do this, or I can do it in my head, whichever. We're going to get 2.2. That means that the scale factor is 2.2, or that 5 has been multiplied by 2.2 to get to 11. That means that 8, the length AB, is also going to be multiplied by 2.2 to get to the length PQ. So we need to do 8 multiplied by 2.2, and that's going to give us our length PQ. We can do this in one of two ways. We can either use a calculator if it's on the calculator paper, or we can use our grid method to multiply, or we can maybe do it in our head. Let's see if we can do it on our head. 8 multiplied by 2 is 16. 8 multiplied by 0.2 is going to be 1.6. And we can add these two numbers up and we get 17.6. So the length PQ, so PQ is going to be 17.6 centimetres. Okay, on the next slide you should be able to see a question that you can have a go at yourself. As ever on these, I'd like you to pause the video. I want you to have a good think about how you might show that these two triangles are similar. You can see there's a couple of lines there, so this is a wordy question. You have to think about exactly what you're going to say. Make sure you've shown some maths as well as just words. And part B says, given that PR is 9.5, calculate the length of AC. So this is doing something very similar to what we've just done. Pause the video, have a go. Okay, so in terms of how you would tell that these triangles ABC and PQR are similar, what I want you to do is to notice that we've got an angle and we've got a side here and a side here. Now, the angles are the same. We can see that straight away. If the length AB has been multiplied by some sort of scale factor to give you the length PQ, and the same scale factor has been used from BC multiplied by the same scale factor, and we get QR, then these two triangles are similar. Let's see if we can work it out. I'm going to first of all use 9 and 6. 9 divided by 6 is going to give me 1.5. And let's just see if the same scale factor has been used on the other one. Is 5 multiplied by 1.5 7.5? Yes, it is. So by the information that I've just written down and the words that I've said, we should be able to say that these two are similar. So the key things, we've got side, angle and side, where the two sides have been increased by the same scale factor and the angle in between them is the same. It says, given that PR is 9.5, calculate the length of AC. Well, we've worked out the scale factor, so what we need to do now is 9.5 divided by the scale factor, which is 1.5. We're going back the other way, and we will get our answer, which is going to be 6 1/3. Now, 6 1/3, it says, give your answer to a sensible degree of accuracy. We'll round it down to, and we'll say that's approximately 6.3 centimetres. And that's going to be good enough for us. Hopefully you got those answers. It'd be well worth you listening to this little bit again, making notes on the words that I've used, because these are key in terms of answering these explain how you can tell questions. There's often a couple of marks available here, and you need to be really precise with the words that you're using. As ever with the videos that I've been making, we do a revision card section at the end. This one's on similar triangles, and what I've said here is that similarity doesn't just mean they look a bit alike. They're going to have the following facts as well. They're going to have the same angles, and that the sides are in the same proportion by some scale factor, whatever that scale factor is, but it's got to be the same scale factor for all three sides. And if you want to draw yourself a little picture, you might draw a triangle like this and a slightly larger one, and you can show that the angles are the same like this. You can do 3 on there if you want to, so they're all the same. And if this is A, B and C, then this one is going to have the same scale factor. You might want to use a number. You might want to say that that's like 3A, 3B and 3C, or if you prefer, you might want to use another letter. You might want to call it N for just some sort of number, and you might say that it's N multiplied by A, and N multiplied by B, and N multiplied by C. The key thing is that this bit is the same on all three sides. Okay, as ever, good luck in your exams. Hopefully this has been useful. If you need any more information, of course, you can always send me a message on Twitter at Mr_G_Walton. Good luck. Bye.